Inside the Auto Show with WWJ's Jeff Gilbert is presented by OnStar.
We're standing in front of one of the most eagerly awaited vehicles here at the North American International Auto Show, the 2010 Toyota Prius. Bill Reinert's with us. He's the manager of advanced technology for Toyota. So, Bill, what about the thumbnail update on what you've done with the Toyota Prius? Obviously, a lot of changes in this vehicle.
Yeah, it's pretty all new from stem to stern. We've kept the iconic shape, and you know it's a Monopoly piece in one of the Monopoly games. So we've kept the iconic shape, but every panel is different. From 100 yards away, you'll tell it's a Prius, but up close, there's a lot of stuff that's changed on it. The interior cabin, we made it 5 cubic feet bigger on the inside, but kept the outside dimensions. So there's even more space than before, and the people that out there that already own a Prius will be shocked to learn that we've been able to make it bigger. On the engine, we've completely changed the engine. We've moved from the 1.5 liter to the 1.8 liter. It's not just an engine upgrade, it's a whole new family of engines. It still is an Atkinson cycle engine. We have managed to reduce the size on our power components, our inverters, our AC-DC and DC-DC bus. Our motors are smaller and lighter. Our magnets are better. And so we've ended up getting a car that has 4 more miles per gallon. It's rated overall at 50 miles per gallon. That's our target. It's faster than the old car. It's bigger than the old car. And we've got some neat tricks in store for the customers too.
One of the interesting things that I picked up from the press conference is not only have you used the engine to improve the fuel economy, but also the design, that you've made the vehicle sleeker, and that's something a lot of people don't really think about.
Yeah, this is running a 0.25 coefficient of drag. I think it's the best in the industry. And the coefficient of drag is how the air moves over the car. And it's a lot of complex design elements. We use computational fluid dynamics, which is computer-aided modeling, to shape just crazy little things like the stalks that hold the mirrors on the sides up. So it's how the air moves over the top of the car, how it moves on the side of the car, and actually how it moves under the car.
Now, are there things you learned from a vehicle like this that will go into a Camry, Corolla, or another Toyota?
Sure. From the aerodynamics, those transfer over immediately. And it might not be that we make everything shaped this way, but individual pieces, as I said, how the side mirrors attach. That's exactly how it is. Now, from how we've made our power electronics so small, and then the heavy-duty stuff, the inverters and the motors, you know, we've got quite a few hybrids on the market. We're showing a plug-in hybrid here. We're showing an electric car. And then Lexus has hybrids too. So we can take the same process that we've used to reduce the size of these power electronics and carry it across to a whole range of different applications, because each car has a different set of power needs if it's got a bigger or smaller engine.
Thank you very much, Bill Reinert from Toyota. Thanks for joining us, and there is more to come from the North American International Auto Show.